Hello friends, welcome. ನಮಗೆ Tech Talk today electric technology ಸ್ವಾಗತ. So in this video we shall discuss about few more selected questions solution useful for AE exam of KPTCL 2022. This is the second video of this part. So if the common base DC current gain of a BJT is 0.98, then its common emitter DC current gain is we need to find out the DC current gain of BJT. So the formula to calculate the current gain, as you can see here, it is beta is equal to alpha divided by 1 minus alpha. Whereas beta is a common emitter current gain and alpha is a common base current gain, right? So we need to find out the DC current gain, which is basically beta, and DC current gain is already given as 0.98. So if we apply this formula, then we'll be able to get the solution for this formula as beta is equal to 49. Okay, so beta is equal to 49, which is option D. Let us look into the next question, friends. In a BJT cascade pair, so if a BJT is connected in series, it's called as a cascade. The meaning for cascade is if a BJT they are connected in series. Okay, if BJTs they are connected in parallel, then they are called as cascode. Okay, let us look into the solution, friends. So this is the emitter, collector, base, emitter, base, collector. Okay, as we can see here, a capacitor is connected between. If we can trace out the complete path, then this is the path, that is C is connected between a collector and base. Okay, now if you can just look at the answer available here, which ends with base. So we have two options available. This common emitter follows common base, or common collector follows common base, right? Now if you can just look at the answer, which is between C and D, right? So as you can see here, the common collector follows the common base is the correct answer for this question. Okay, for this question the correct answer is option C. Okay. And let us put into the next question, friends. A gray code for a number 7 is, right? So there is something called as actually binary code and gray code. Okay, so for number 7 there is a gray code that we have to calculate. So this is actually a number table which is very easy to remember, which gives idea of a decimal number, equivalent binary number, and gray code. Okay, what is expected is for 7, for a decimal number 7, binary code is 1 1 1 and gray code is 1 0 0. Okay, now by a simple comparison we'll be able to know that the correct option is D. But how to obtain this solution? Okay, what is the procedure to obtain this solution? Let us try to understand. Now we know that 7 is a decimal number and its equivalent binary number is 111. Okay, its equivalent binary number is 111. Now always we can just look at the comparison between binary number and gray code, MSB remains same. There is no change with respect to MSB. That is the most significant bit. Whatever is there in binary will be there. That is, as you can see here, here it is 0, here also it is 0. Similarly, I will take one example. You can see here it is 1, here also it is 1. Okay, mean to say that obtaining MSB is very easy. Whatever is the MSB of our binary number, it will be the same number. Now, how to obtain remaining 2 bits? Okay, now in order to obtain remaining 2 bits, what we have to do is we have to have a XOR operation, that is exclusive OR operation, XOR operation on the remaining numbers. Okay. Now we can, as you know that 1 XOR with 1. Okay, its answer will be 0. Similarly, one XOR with X from its answer will be 0. And already we know that as a part of our MSB, we already have 1. Okay, so that the expected answer for this question, we have obtained it as 1, 0, 0. Okay, so this is what is the solution for gray code and binary number. So let's look into the next solution. Which of the following technology results in least power dissipation? So as regard as least power dissipation is concerned, it is always CMOS family. It's always CMOS family which consumes very less power. Next, the voltage gain of a common emitter amplifier is. Okay, the voltage gain of a common emitter amplifier is directly proportional to collector bias current. Okay, so this is directly proportional to collector bias current, which is option A. Let us look into the next solution, friends. Then, number of comparators needed to build a 6-bit simultaneous A to B converter. So the formula here is, as you can see, we need to apply it as 2 to the power n minus 1. Right. So here, as you know that n is 6. So it is 2 to the power 6 minus 1, which will be 63. Okay. So as you can just look into the solution available here, the correct answer is option A. Okay, friends, next we shall look into the solution for another question. For which of the following UV light is used to erase the stored contents? Okay, so this is with respect to ROM, this is read-only memory. So where ultraviolet rays are used. Okay. EPROM. So as you can see here, EPROM erasure is pretty cumbersome. It requires a physical removal of the chip and exposure to a special kind of UV. Okay, so UV rays are always exposed on EPROM to erase it. So this is the answer, option A. Let us look at the next question then. A 4-bit synchronous counter uses flip-flops with propagation delay of 25 nanoseconds. The maximum possible time required for change of state will be. Okay, remember that there are actually two types of counters. One is called as a synchronous counter, and another one is known as asynchronous counter. There are two types of counters. One is synchronous counter and another one is asynchronous counter. So whenever there is a synchronous counter, it has a very good characteristics like all the flip-flops change simultaneously, whereas in asynchronous, the propagation delay will be there, right? So the synchronous counter will provide very least delay. Synchronous counters will provide very least delay compared to asynchronous counters, and we know that the question associated in this case is with respect to the synchronous counter. But as in the case of synchronous counter, all the flip-flops will change their states simultaneously. Of course, the maximum possible time required for obtaining change state will be only 25 nanoseconds, as the change is happening parallelly or in a synchronous manner. Now, this is with respect to a feedback in a control system. For all the purposes it is required. So it is actually required to reduce the sensitivity of the system and also to increase the loop gain. So the expected answer for this question is 1 and 3 option, which is option D. Let us look into the last part of solution in this series. The gain margin of the system in decibels is negative, then the system is. Okay. Whenever the gain margin is negative, system is unstable. Then remember that whenever the gain margin is 0, system is marginally stable, and whenever the gain margin is positive, system is stable. Now with this information, we can mark that whenever the gain margin is negative, because whenever our current gain margin is negative, the system is unstable. The system is actually unstable. So the expected answer is this is not there, this is not possible, this is not possible, this is not possible. Unstable is the expected answer. That is, whenever it is negative, unstable, positive, stable, there is marginally stable. Thank you for watching this video series. Thank you all.